Hi everyone. In this video, we will be discussing some solutions to some of the important questions from the chapter Chemical Kinetics asked in the JEE main exam held in April 2023. So let's take the questions one by one. See, in this first question that we come across, what is asked? For the adsorption, for the adsorption of hydrogen on platinum. So there is a adsorption of hydrogen on platinum. Hydrogen gas is adsorbed on platinum. What is given? The activation energy is 30 kilojoule. So for this adsorption of hydrogen on platinum, activation energy is 30 kilojoule per mole. Next sentence. And for the adsorption of hydrogen on nickel. So next what they have done? The adsorbing hydrogen on nickel. For this, the energy of activation is how much? 41.4 kilojoule, right? 41.4 kilojoule per mole. 4 kilojoule per mole. Now the question is the logarithm of the ratio of the rate. What is the question? Logarithm of the ratio of the rate. Rate in the sense we can go for rate constants. I'll consider K2 by K1. For that we have a standard equation. The logarithm of the ratio of rates of chemisorption. Chemisorption means the same adsorption on equal areas of the metal at what temperature? At the temperature mentioned is 300 Kelvin. So at 300 Kelvin, the question asked is the logarithm of rates of the two processes is how much, right? They have given the ln 10 value as well as R value. So here we have two reactions and two energy of activations. The higher one I will take it as EA1 and the other one I will take it as EA2. So now the direct formula that we have, the standard one that we have is log K2 by K1 is equal to delta EA by 2.303 R into T. This is the formula you guys need to remember for this, right? So what is that? Log of K2 by K1 is asked. Now let us find its value. Log of K2 by K1 is delta EA. What is delta EA? Energy of activation whose value is higher minus energy of activation whose value is lower. EA1 by EA2 divided by 2.303 into R. R is a universal gas constant whose value is 8.314. But 8.314 is joule, but other quantities are in kilojoule. I will write 8.314 into 10 raised to minus 3 so that it is also expressed in kilojoule. Now coming to temperature, temperature is given to be 300. Now what is in the numerator? EA1 is 41.4, EA2 is 30 divided by 2.303 into 8.314. You have come across this value many times. You should know this value as 19.147 into 10 raised to minus 3 into 300 is nothing but 0.3. So in the numerator 41.4 minus 30 is about 11.4. In the denominator we will be getting about 5.7. So this would be approximately 2. So our answer for log of rates of these two processes is 2. So your answer for this is what? 2. Got it? Let's go to next question. Yeah. A gas, A is a gas, B is a gas, C is a gas. And what kind of reaction is this? First order reaction, right? So what is the reaction being given here? A gas will give me 2 moles of B gas plus C is a gas and its order is first order. It's a first order. The initial pressure, initial means what? Before the reaction begin, I was having only A. So pressure due to A is how much? Initial pressure is about 800 mm. So initially pressure due to B and C would be 0 because they are products. Initially no products would be formed. So whatever 800 mm pressure जो दिया है, Like whatever is the initial pressure they have given, that is the pressure purely by A. Right? Now next sentence. The 800 mm pressure, the 800 mm of Hg, which is increased to 1600 mm after 10 minutes. After 10 minutes. Now, after some time, like at 10 minutes, what has the pressure become equal to? 1600 mm it becomes. But at the same time, we should remember that in the due course of time, in that 10 minute, certain amount of A will be getting converted to product. Let us take it as X. So in that 10 minute, if X amount goes as a product, what amount of A is left? It was 800. So now 800 minus X is left. Now, how much that X will get converted to product? Looking at the stoichiometry of the equation, 1 mole of A can give me 2 mole of B and 1 mole of C. So, therefore, X mole of A would end up giving me 2X mole of B and X mole of C. So, after 10 minutes, what all I am having? I am having 800 minus X mm of A, 2X mm of B, X mm of C. So all this put together at 10 mm, what is the pressure given? 1600 mm, right? So this 1600 mm जो है, that is the total pressure exerted by A, B as well as C after 10 minutes. So after 10 minutes, the amount of A I am having is 800 minus X. Amount of B I am having is 2X. Amount of C I am having is X. So now this is going to be what? 800 plus 2X is equal to 1600. So that makes 2X is equal to 800 and therefore X is equal to 400. Right? So X is equal to 400. Now what is X? X is the amount that is converted to product. What was the initial amount of A? Initial amount of A is what? How much? 800. So after 10 minutes, T is equal to what? 10 minutes. How much of the A is left? How much of the A is remaining? It was how much? 800. How much is it left? 800 minus X. Now what is the X? 400. So how much is left? 400 mm. Now carefully compare this. Initially what was the pressure of A? 800. Now how much it is? 400. What is the time it has taken to get converted from 800 to 400? The time taken is 10 minutes. It was 800, it exactly became half. So that time is called as half-life period. So half-life period is how much? 10 minutes. Got it? Because initially it was 800 mm. Within 10 minutes it became exactly half, that is 400. So therefore that 10 minute I will take it as half-life period. Now the next sentence. What is the total pressure of the system after 30 minutes? So we know that half-life period is how much? 10 minutes. So now total time given is how much? 30 minutes. Within 30 minutes, how many half-lives will be there? 3 half-lives. Because 10 minutes is 1 half-life, 30 minutes is 3 half-life. Now question is total pressure. What is the total pressure after 3 half-lives? Okay, now let us find that. Now let us go back again to the equation. What is that equation? The equation is A is a gas giving me 2B gas plus C gas. Got it? So what was the initial pressure? The initial pressure was 800 mm. Initially this was 0. Now after 30 minutes, pay attention. After 30 minutes means how many half-lives? 30 minutes is 3 half-lives. So from 800 you have to travel 3 half-lives. Pay attention. 800, if you travel 1 half-life, it becomes 400. If you travel 2 half-lives, it becomes 200. If you travel 3 half-lives, it becomes how much? 100 mm. Got it? 800, half is 400, half of 400 is 200, half of 200 is 100. So 3 times we have to get the half-life. So 800 is becoming how much now? 100 mm. Got it? So that means how much has gone into the product? It was 800. After 3 half-life, it becomes 100. That means how much is gone? 700 is gone. Now look at the stoichiometry. 1 mole of A is giving me 2 mole of B. So 700 would give me 1400 mm of B. 1 mole of A is giving me 1 mole of C. 700 would give me 700 mm of C. So after 30 minutes and after 3 half-lives, the total pressure is 100 mm by A, 1400 mm by B, 700 mm by C. All put together, it will be about 2200 mm. So your answer for this question is 2200 mm. Let's go to next question. For the reaction, for the reaction, Ag is giving 2b plus Cg, right? So we have a equation where A gas is in equilibrium with the 2b gas plus C gas. Okay. For a given reaction, if the initial pressure, again, initial pressure means the pressure of only reactant, because initially you will not be having any product, so therefore B and C are 0. For the given reaction, if the initial pressure is 450 mm and pressure at time t is 720 mm, so let the reaction take place for some time t. Then let me assume that x mole of A will be going to product. How much of A is left? 450 minus x. So 1 mole of A can give me 2 mole of B. X can give me 2x mole of B. 1 mole of A can give me 1 mole of C. X of A can give me x mole of C. So after t time, so what is the after time t, what is the pressure? 720 mm. So 720 mm is the pressure due to A as well as B as well as C. So therefore 720 mm is nothing but 450 minus x plus 2x plus x. So that is 450 plus 2x on the right hand side is equal to 720. So 2x is equal to 720 minus 450. That would be, 270. So therefore x is equal to 135 mm, right? So till here we are done, right? Now what is asked? Fraction of A decomposed under these conditions. Now how much was A? How much was A initially? That was 450 mm. How much is dissociated? X. But what is X? 135 mm. So now they have asked you fraction of decomposition. How much is decomposed? 135. Out of how much? 450. So fraction is 135 upon 450. That would be about 0.3, which I can write it as 3 into 10 raised to minus 1 m fraction is decomposed. And they have written it as x into 10 raised to minus 1. So 3 into 10 raised to minus 1 is nothing but what? X into 10 raised to minus 1. So therefore your x would be equal to 3. Let's go to next question. Yeah. Here, the reaction 2NO plus Br2 giving 2NOBr. This is the reaction we are having. This is taking place through the mechanism. Mechanism means in detail sequential steps they are giving. So in the first step, the fast reaction is in equilibrium, and in the second step, that is the slow step, right? What is asked after giving the mechanism? They have asked you overall order. So how do you find overall order generally? You will be finding it by applying the law of mass action to rate determining step. What is rate determining step? The slow step. Which is the slow step? The second one. After applying the law of mass action to the slow step, I will get rate is equal to rate constant into concentration of the reactants in the slow step. Concentration of the reactants in the slow step are NOBr2 and NO. So these are the reactants in the slow step. So therefore rate of the reaction is written like K into NOBr2 into NO. So what is the coefficient of NOBr2? 1 as well as NO is 1. So power of NOBr2 is 1 as well as NO is 1. So I will take it as equation number 1. Now going to the first one, which is fast as well as in equilibrium. So if you look at the slow step reactant, what is there? NOBr2. This NOBr2 is not only in the slow step, NOBr2 is also in the fast step, which is in equilibrium. So applying the law of chemical equilibrium to first step. For the second step, we have applied law of mass action. We have applied law of mass action to the slow step. And for the first step, we are going to apply the law of chemical equilibrium. So applying the law of chemical equilibrium to first step, what am I going to get? Applying the law of chemical equilibrium to first step, I'll get Kc equal to NOBr2 by NO into Br2. So therefore, I will be having NOBr2 is equal to what? Kc into NO into Br2. This is, I'll take it as point number 2, right? So in the first one, the rate is equal to K into NOBr2 into NO. In the second one, value of NOBr2 I am getting. So this NOBr2, I will substitute 2 in 1. Because in second equation I am having the value of NOBr2. The value of NOBr2 will be substituted in equation number 1. So after substituting in equation number 1, the equation number 1 becomes what? So what is NOBr2? NOBr2 is here. NOBr2 is what? Kc into NO into Br2. Apart from NOBr2, what else is there? NO is there. So now K into Kc, I'll write it as K dash. NO into NO square, Br2 is as it is raised to 1. So this is your rate law. In this rate law, what are your powers? 2 plus 1. So 2 plus 1 is equal to 3. So that makes the order of the reaction as next one. Yeah. In the next question, a molecule is undergoing two independent first order reactions. A molecule like A is undergoing two independent reactions, like A is giving B also, A is giving C also, whose respective half-lives, the respective half-lives are how much? Here the half-life is 12 minutes, here the half-life is 3 minutes. Now the question is, if both reactions are occurring, so here I am having A where A is giving B also, A is giving C also, right? If both reactions are happening, then what is asked? The time taken for 50%, that means half-life period. Half-life period. The time taken for 50%, that means half-life period is how much? Right? So if we consider this as a parallel reaction where A is giving B as well as C, I'll consider A giving B is having a rate constant of K1, A giving C is having a rate constant of K2. We have, what exactly is K? For first order reaction, K is 0.693 by T half. So that clearly implies that K is inversely proportional to half-life period. So therefore, I will write K1 as 1 upon first half-life, K2 as 1 upon second half-life. So they have asked for average half-life. They have asked for average half-life. Got it? So therefore, average K, 1 by K will be equal to. So K is equal to, so what we are having here is, yeah, K is equal to 1 by T half 1, K2 is equal to 1 by T half 2. So now what we will do is, let us have 1 upon T half. This is of the parallel reaction is equal to 1 upon T half of the first one plus 1 upon T half of the second one. So for the first one it is how much? It is 12 minutes. Plus for the second one it is 3 minutes. So that will be 12. 1 plus 4, that will be 5 by 12. So 1 by T half is 5 by 12. So therefore the T half of this parallel reaction would be 12 upon 5, which would be 2.4. So 2.4 minute would be our answer. 2.4 minute would be our answer. So these are some of the important questions picked from 2023 April from only the chapter Chemical Kinetics. Thank you.